everyone. Thank you for joining us today for one of our Opportunity Series webinars for the Master of Science in Innovation and Venture Development. As you may know, if you are one of our admitted students or if you've attended one of these webinars before, the MSIVD is a brand new master's program that's starting this fall 2020 at ASU through a partnership between the Ira A. Fulton Schools of Engineering, the W.P. Carey School of Business, and the Herberger Institute for Design and the Arts. My name is Jackie. I'm the graduate coordinator for the MSIVD program. I'm here to work with our students through the admissions process and in an academic advising capacity. I want to get started today by going over just a quick agenda of the topics that we'll be covering. In just a few minutes, I will introduce you to our program director, Cheryl Heller, who will give you a brief introduction to the program. We'll then be hearing from one of our MSIVD faculty, Zak Holman, who will be talking about ideation, formation, and growth. I will then have a few minutes at the end to talk to you about the admissions requirements and what you can expect from the application process. I'll also have some information for you about the tuition and program costs for MSIVD. And then we do expect to have a few minutes towards the end for a Q&A. So if at any point throughout this presentation you have any questions for any of us, please do leave them in the Q&A section of the Zoom webinar, and we will get to all of those for you at the end. So right now I'm going to turn it over to Cheryl Heller, our program director.
Thanks, Jackie, and welcome everybody. Jackie mentioned that this is one of a series of information sessions. We will be doing them about once a week for the next month, leading up to our next deadline in June. So keep your eye on the schedule if you're interested. And if you haven't heard one yet, I'll just recap what's unique about this program. Jackie mentioned that it's a partnership between 3 schools, and these are the 3 disciplines most important to the success of any venture. And we have spent the last at least year and a half working on integrating the curriculum into a single-minded, student-centric curriculum. We welcome all undergraduate degrees. The program is experience-based, so you will launch a venture while you're in school. And a big part of the offering is an extraordinary ecosystem that we've put together of not only faculty like Zak, but industry leaders and mentors and other organizations and businesses that can help our students succeed in what they want to launch as an enterprise. Even though we, like everyone else, could never have anticipated the changes in the world in the last few months, the economic and social and industrial fallout from COVID, we still believe that this is the perfect program to prepare people to lead the kind of generative innovation and to develop the resourcefulness that we need now. So I am delighted to have one of our founding IVD faculty here. Dr. Zak Holman is a rock star, and you'll see why. He's a very busy one, and we're really lucky to have him for the next brief period of time. So I will take no more of his time and turn it over to Zak.
Thank you, Cheryl. I do want to just briefly introduce Zak to all of you today. Dr. Zak Holman is an associate professor at ASU in the School of Electrical, Computer, and Energy Engineering. He runs a research lab here at ASU when he's not teaching, where he and his team solve problems that are both interesting and important. When he is teaching, he's consistently rated as one of the best teachers his students have ever had, and we're really happy to have him as a founding faculty member for the MSIVD program and to have him here to talk with you all today. Zak, over to you.
Great, thank you very much, Jackie and Cheryl, and thanks everyone for joining us today. I see some familiar names in the attendee list. So I've been at ASU for 7 years, and I wanted to tell you a little bit about how I ended up here, because a unique thing about this program is in bringing together these 3 different schools and 3 different disciplines, we're also bringing together faculty from each of them. So I'm representing engineering in the MSIVD program, and I came about as an electrical engineer through a sort of tortuous path, and I consider myself a mutt academically. I started my education at Reed College in Portland, Oregon, where I was known for my good looks and long hair, as you can see. And I studied physics, actually. And I was required to write an undergraduate thesis at Reed, and I wrote my thesis on how electrons move through materials. And that sparked my interest in material science. And so next, I went to the University of Minnesota and transitioned to mechanical engineering. And I thought that I really wanted to do something with my hands, and that mechanical engineering would allow me to do that more than physics. And at the University of Minnesota, I used plasmas, ionized gases. You can see this glowing purple-pink material inside a glass tube there is a plasma, to make materials. And we always said we were going to make great solar cells with the materials that we made, but I never really got a chance to do that during my PhD. And so next, I went to Switzerland in the small town that had a university and an institute that was very good at making solar cells. And I studied microelectronics and more the device side, less the material side of solar cells. And that led me to ASU, which you can see next here, where I'm in the School of Electrical, Computer, and Energy Engineering. I don't have any degrees in electrical engineering. I make do in sort of my broad experience. And I think this broad experience lends itself very naturally to entrepreneurship. And I think one of the most exciting things about this new program is putting together cohorts of student teams that have engineers, that have designers, that have business people, so that they can learn from one another and develop some of the breadth needed to succeed in a startup company. So on the next slide, I want to tell you today about Swiftcode, which is about a 4-year-old venture now. And I want to talk about it in terms of Studio 3 within the MSIVD program. It's a studio that I will be co-teaching with a design professor starting next spring. And the studio is called Explore, Fail, Solve, a series of necessary steps that have to be repeated over and over in startups and entrepreneurships. And so I want to tell you about how Swiftcode has lived that experience, the experience that we'll be teaching and living collectively within the studio. On the next slide, you can see how Swiftcode came to life. This is a photo of Peter Firth, who was a PhD student in my research group, and spent his time investigating a new technology that became the founding technology of Swiftcode. We didn't decide to form a company in a very purposeful sense. Instead, what happened is Peter became interested in entrepreneurship and business and took a course at ASU that was offered in the School of Business that had a pitch competition at its end. And the instructors of the course tell me that Peter was terrible at pitching at the beginning of the semester, but by the end, he had figured it out and had become very good at it, because in fact he won first place. And he was the only engineer in that competition. Everybody else was business students, and so he was very surprised and delighted to come out on top. But we had a problem, which was that we now had a $50,000 check that had to go into a business bank account, not a personal bank account. And because of this, we created Swiftcode. And then we had to figure out what in the world to do with this company and how it should grow and thrive. And this is the process of exploring, failing, and solving that we explore in Studio 3. Per the next slide, Peter actually managed to win about $175,000 in business plan competitions, including at the prestigious Rice Business Plan competition. And this convinced us that we weren't crazy, that Swiftcode had a future. We go on to the next slide. So Swiftcode is a company with the aim of making ordinary surfaces extraordinary. And what that means is it's developed a technology to add thin layers of materials to surfaces, like a piece of glass, that change the properties of those surfaces. Maybe how it reflects light, how it interacts with electricity, how it conducts heat, things like that. And Swiftcode's present business model, if we click next, is to sell pieces of equipment that do this, that add this thin layer or coating as we call it to surfaces, and also to sell the raw materials that you put into the equipment in order to add this thin layer or coating to the surface. And Swiftcode's customers, which you can see next, are manufacturers of windows, architectural glazing, that add thin layers to those windows, and also manufacturers of solar panels. And in fact, Swiftcode's first product, which gets applied to both of these types of glass, is a self-cleaning layer that absorbs ultraviolet light and performs a chemical reaction that decomposes soilants, dirt, grime, things like that. However, Swiftcode didn't start with this business model or with these customers or even with this technology. It got to this point through a series of exploring, failing, solving, and I want to share a couple of those experiences with you. On the next slide, you see that I'm an engineer. My first thought, if you say explore, fail, solve, is, we must be talking about technology problems. That's where we do the solving. But in fact, that's a uniquely engineering perspective and kind of the wrong one when you start startups, at least in my experience, because the most important place to explore and fail first is actually in your customer. And you can see that on the next slide. When Swiftcode began, we first thought that we would supply coatings of quantum dot light emitting material to the new and emerging quantum dot television display industry. Through a series of customer interviews in which we talked to manufacturers, business development leaders at those manufacturers, technologists at those manufacturers, etc., we found that companies like Samsung didn't have a problem that we could solve. Their problem was that the raw material that emits light wasn't good for their job. They have a good quality material that emits lots of light that's toxic, and they have a non-toxic material that doesn't emit a lot of light. We didn't know how to solve that problem. The problem we could solve is taking whatever material they had and putting it down in a nice way as a thin layer or coating in a television. So the problem we found there was we thought we had found a customer, but their problem didn't line up with our potential solution. We then moved on to other spaces, and we did some sampling, provided some samples for the manufacturer of Tesla's front windshield. And they had a problem that we thought we could solve. They were trying to reduce the reflection coming from the windshield so that if you're sitting in the back seat of a Tesla at night, you don't see the dials and displays reflecting off the front windshield into your eyes. That can be solved with an anti-reflection coating. This is something that Swiftcode could solve, but it turned out, once again, through talking with manufacturers, both of automobiles and of glass manufacturers, glass coaters, and the competition, that the road to introducing a new technology into the automotive market is very long because they are extremely demanding. So here, we thought we had a problem we could solve, but we were likely going to run out of money as a company before we could ever get to market with that product. Yet another explore, fail, solve, well, not yet solve, pathway as a customer, in terms of customers. On the next slide, you'll see a photo here of a sheet of glass. These sheets of glass are usually 10 feet by 30 feet in size. They're massive, rolling along those rollers through a glass coating and manufacturing line. We finally decided that our first customer were glass manufacturers and glass coaters, and we entered into a joint development agreement in which those companies were willing to put their money towards the development of Swiftcode's technology, which really convinced us that we had found the right customer. But now we had to figure out what our business model was to capture the value we created with those customers. And our first thought was the same as many groups coming out of academia. I know, we'll license the technology. And for each piece of glass that the manufacturer makes with our coating on it, we will charge them. And so therefore, as they make more coated pieces of glass, we'll just get money by licensing this IP and deriving royalties. We tried this business model, this is the explore part, by simply talking to our customers and potential customers and saying, hey, we're still feeling out our business model, but this is what we're thinking at the moment. And This did not fly with our customers. They had several problems. The first was that they didn't like the idea of 10 years down the road paying royalties on something they feel like they purchased 10 years ago and did a bunch of development internally, and it no longer felt like something that we were providing, but something rather that they had developed. And a good way you know if your customer's telling the truth on something like that, or whether they're just trying to scare you away, is you ask them, well, have you done this before? Can you give us examples? And if they really have not done it before, and you can find that out, well, then you should be scared and potentially looking for a different business model. Another problem was it turns out a lot of glass manufacturers are private companies, including the ones that we were interacting with. So they don't actually report to anybody except for internally their numbers of the amounts that they manufacture and their revenues and that sort of thing. So we were going to have trouble accessing the information we would need, in fact, to actually execute this business model and appropriately charge them. And it was actually our customers who suggested the business model that we settled on. So in fact, it was our customers that solved this problem. They said, we have to buy materials anyway. Sell us the materials and roll your royalty into that. I didn't like this at first. I thought, we're not a material supplier. We don't necessarily offer innovation there. We would be going to an outside toll manufacturer, contracting them to make the materials, put our label on it, and supplying it to our customers in order to capture this value stream. But it turns out it makes a lot of sense for a lot of reasons. So with an understanding of our business model, which I mentioned at the beginning was to sell equipment and to sell these raw materials, we moved on to some technology problems, which are on the next slide. In particular, this thing that I'm holding is a small prototype of a piece of hardware into which you feed raw materials, gases and vapors, it turns out, and convert those into this film or coating on top of a substrate. Now the problem is that that's about 6 inches wide, and as I mentioned, the pieces of glass that we need to coat are 10 feet wide. So talk about a scaling challenge. This really was a technology challenge. And the first thing we thought is, I know this is a linear piece of equipment, we'll just make it longer. So you can see Hugo here holding the bigger one. But there are challenges, and this worked, going to 15 inches, but there are challenges in going all the way to 10 feet wide with these pieces of hardware. So through, again, some querying and talking with customers and others who've been in this field, we learned of a technique that's previously been used successfully with different types of technologies. It's called stitching, where you would put 2 different pieces of hardware side by side with a slight overlap between them. The glass would move underneath, and you would try to make the seam where this one's putting down some material, this one's putting down a coating of material. You try to make the seam between them disappear. And if you can do that, then you can go as wide as you ever wanted just by repeating that as necessary. So this was our approach to scaling, which is specifically a technology problem. Final slide about explore, fail, solve here. One that certainly as an engineer, I never thought about. I'm sure those who have training in business probably would. That was in personnel. It turns out it's challenging when you're a 2-person startup company. You've been in business for a year, you don't have revenue yet, you don't necessarily have more than 24 months of runway in investor funds to hire the best people and the people that you need. And our first hire at Swiftcode, unfortunately, didn't work out. It was the wrong person. It was a person who had experience in the glass industry, 5 years of experience, and would have been right as hire number 10 or hire number 15 once we had gotten things together and we were just working on tweaking and going into a manufacturing environment. But turned out we needed someone who was still more R&D, incredibly flexible, versatile, could solve all sorts of different problems as they popped up. And so I think about 6 months after we hired our first employee, we also let him go. And that was quite a devastating experience for the founders, us, for the company, and for him. But it was also the decision that had to be made for the company to survive. And we subsequently have made fantastic hires at the company. This is in fact Peter, one of the co-founders, and Shannon, one of our engineers, working on a piece of equipment. You can see in the middle of the screen that 15-inch piece of hardware with all the attachments to deposit coatings. So this was a learning experience where a bit more of the explore, I think, could have perhaps avoided a fail, or let's say had the failing before the hiring stage, and so that there wouldn't have had to have been the experience of letting someone go. If we move on to the next slide here, just want to point out that if you do these things well, then like Swiftcode, you can attract funding. Swiftcode's been successful in getting government grants, and specifically having those align with the needs of its customers. Probably the most important thing on here is not the investor capital towards the bottom, but rather that joint development agreement where we have a customer and partner who has invested money not invested money, sorry, they've entered into a joint contract in which they're paying Swiftcode, not by taking equity, but just by paying for development of this technology that they think will transform their business. So if you use this, this structure of explore, fail, solve that we're going to cover in Studio 3, then you also can continue to grow your venture, and it will thrive. And I presented it here as if, like, yes, we did customer, and then we went through business model, and then technology, and then internal business workings like personnel. But in fact, it's messy. All of these different explore, fail, solves are going on simultaneously, and it's oftentimes only in hindsight that you can look back and say, oh yeah, that makes sense. We learned about this, and we had this thing which ended up being a fail because we learned about these other things, and then we had the solution. One of the things I'm most excited about the MSIVD program is working with the students, with the cohorts, to make it such that this becomes clear not only in hindsight, but such that you understand the structure in advance, that you can be much more efficient about it than Swiftcode was. Swiftcode didn't have this sort of training, and that you can recognize as it's happening where you are in that structured process. So with that, I think that's my last slide, and there will be a chance for Q&A after a few more by Jackie and Cheryl. Thank you.
Thanks so much, Zach. As he just mentioned, if you all do have any questions for him, please be sure to leave them in the Q&A section of your webinar screen, and we will be sure to get to those towards the end. In the meantime, I do want to take just a couple minutes to talk to everybody about the application requirements for the MSIVD program if you haven't submitted an application yet. So you will need to submit your undergraduate transcripts. ASU does allow students to upload their unofficial transcripts through the online application. So if you have access to your unofficial transcripts, that's the quickest way to get those added when you apply. If you're an international student and you are looking for a way to meet the English proficiency requirement, one good option to look at right now would be the Duolingo English test, which ASU is currently accepting for students who may be affected by testing center closures due to COVID-19. So that's a great testing option to look at if you're looking for something that you can do from home, from your computer. The only other things that you need in order to submit the initial application would be an up-to-date copy of your resume and a letter of intent. The letter of intent is an opportunity for you to introduce yourself to our program faculty, to talk about what interests you in the MSIVD program, what you are passionate about, and what you would hope to accomplish through the program. It should be no more than 3 pages or so, double-spaced. And like I said, it's really our first opportunity for our faculty to get to know you through the application process. Our next application deadline is on June 30th, so I do encourage you to apply by that date if you haven't done so already. Once your application is submitted, it will be reviewed by our faculty, and then if you move on to the next stage in the admissions process, we would contact you with some additional questions to answer and to schedule an online interview as well before making a final decision. So the link at the bottom of the screen is to our MSIVD website, where you can then find a link to start the application if you haven't done so already. And then I did want to just quickly cover some information about the tuition and fee structure for this program. So on this screen, you will see a breakdown of the estimated cost for this one-year program based on your residency classification. So it's a 1-year, 30 credit hour program. You would be taking courses in the fall, spring, and summer semester. And as you will see here, you would be paying the ASU tuition and fees based on your credit hour enrollment. And then there is a program tuition as well of $4,000 per semester in this program. So you can look at this graphic to get a sense of what the overall cost would be estimated based on your residency classification. These numbers are based on the current academic year's tuition numbers, so they might change slightly as the new numbers are announced, but this is going to be a good estimate for you of the overall program cost. And then one other point that we like to bring attention to is that it is a STEM designated program. So there are scholarship programs that are structured specifically to support students in STEM programs. There are also expanded benefits for veteran students as well as international students in STEM programs as well. So we do have just a few minutes left in our presentation here. If you haven't done so already and you have any questions for us, like I said, please put them in the Q&A section of the webinar screen. And I am just going to take a look here to see if we have any questions already. So Zach, I see we have a question here for you. Someone asks, did Swiftcode utilize the I-Corp program to fund interviews with potential customers, or did your team do that on their own?
That's a great question. For anybody on the line who isn't familiar with the I-Corp program, this is run by the National Science Foundation, and it's a program that teaches the process of what's called customer discovery. And it's a process during which a team develops hypotheses, not of the scientific sort, but rather about who their customer might be, what a business model might be, what the customer values, how much value they could capture, et cetera. And then calls people, potential customers, or ideally visits with them in person, asks these questions in open-ended ways, and then does a lot of small mouth, big ear, sort of listening and picking up for key bits of information. And the answer to the question is I participated in the National I-Corp program for a different technology, pre-Swiftcode in 2015. And one is supposed to, in the National I-Corp program, complete 100 interviews, which is a heck of a lot. And I became such an advocate for this that when Peter and I founded Swiftcode, we went through an I-Corp program again, but instead of the national one, we went through ASU's 3-week version, which is a little bit smaller. It's actually a feeder program into the national. This is available for anyone at ASU to take, and you actually get $2,000 for doing so. I highly recommend it. It can provide more information. We use that for Peter to learn the methodology of I-Corp, and then he and I continued thereafter to do customer discovery. And we regularly, still now, 4 years later, have 2 or 3 phone calls per week talking with potential customers and using it as a learning opportunity. So we learned the structure of customer discovery from I-Corp and then have employed it on our own since then. Thanks for the question.
Thank you, Zach. I see that we have another question here from someone asking if the MSIVD program is a dual MSE. So forgive me if I am misunderstanding, but I believe you're asking if it is like a dual degree program. It is a single degree, but it is offered through 3 schools at ASU. So while you're in the program, you will be receiving instruction from faculty from the Ira Fulton School of Engineering, the W.P. Carey School of Business, and the Herberger Institute for Design and the Arts. All 3 of those schools will show up on your transcript and your diploma, but it is just a 1 single degree program. I hope that answers your question. I don't know, Cheryl, if you have any other thoughts that you wanted to add to that.
No, I think that was great. Thanks, Jackie. And thanks, Zach. That was really wonderful.
Okay, so it actually looks like we are just about out of time here today. So I do want to just thank everybody again for being here with us. Thank you to Zach for taking the time to share some of your experiences with us, and thank you to Cheryl as well for being here to introduce the program. My contact information is here if you have any questions or if you're interested in speaking with someone about the program. Please reach out and I would be happy to set that up for you. If we do have any questions as well that we didn't have time to get to today, I'll be sure to follow up with everybody shortly to get those questions answered for you as well. But yeah, I just wanted to say thank you again so much for joining us today, and I hope you have a wonderful rest of your day.
Thank you.